and so on. But these on that sheet are the properties you need to know. They will be on your test. I would advise, with these properties, I would advise making flashcards. And you could put, just as an example, you could put the property on one side and an example on the other side, and you should be able to go both ways on it and quiz yourself. Okay, so that would be a good way to study for the test. Okay, so, and just to learn your properties, because you're going to need them in geometry also. Okay, multiplication property of -1. The product of a number and -1 is the opposite of the number. Pretty intuitive. Notice that this lets you write -a as -1 times a. And that's going to help us as we move down here. So that lets us kind of deconstruct these so we can see that when you're multiplying two numbers with the same sign, the product is always positive. So a negative times a negative is a positive, and a positive times a positive, of course, is positive. And when you're multiplying two numbers with different signs, the product is negative. Now, in this case, we have a negative times a positive, different signs, so the product will be negative. Now, I can cancel here, right? That's 2, that's 1. So this equals -1/10. Okay, so you try this one. What'd you get? 4, exactly. So we know they have the same sign, so it'll be positive. This 6 cancels with that 3, so we have a positive 4. Okay. When multiplying three numbers, you can multiply any two first. That's because of the commutative property of multiplication, which we have now. It's one of our tools. So in other words, you don't have to use order of operations. We can be smarter than that now. We can be a little more efficient than with order of operations by using our properties. Okay, so for example, if you look at this one, if you multiply these together first, that's going to clear this denominator of 7, and then you can multiply it by this. You could also just multiply these two together and then by this one. That would be okay too, but this helps us be a little more efficient. So this, the 7, -7 times the -6/7. Well, this is the same as -7/1. They're both negative, so our product is going to be positive, and our 7's cancel. Right? So this is just +6. And then we still need to multiply it by the -3/4. Well, again, I can put my 6/1. These cancel, right? Because they both can be divided by 2. I've got a negative times a positive, so it's -9/2. You following that okay? All right, so do the U try. What'd you get? -20. Okay, so you could multiply the 6 by the -5/3. You could multiply these together. Maybe we'll do that. So I have -5/3 times 12, which is same thing as 12/1, if that helps you. Then that becomes a 4, because those cancel, and you have -20. All right. So A, B, and C are real numbers. Remember, when we're distributing, we multiply the A times the B and the A times the C, and we'll have the plus in the middle. So this becomes AB plus AC. So an example would be 2 times 5 plus X equals 10 plus 2X. Because I've got to remember to multiply the 2 by that second term as well. This is the same thing because multiplication is commutative. I've just moved the A to the other side. So it's A times B plus A times C. So it's AB plus AC. So in this case, there with the subtraction one, I almost prefer just to look at this rule and remember that C can be negative. So now we're going to identify the terms, the coefficients, the like terms, and the constants. All right, so in this one, the terms, and it seems kind of tedious to write it out, but we'll do it. Because I want to make sure you realize the negative is part of the term, so that's negative xy. The next term is 4. The next term is 3xy, and you guys make sure you're writing this down. And the next term is negative 7. Okay, what are my coefficients in this one? What's the coefficient here? -1. This is not a coefficient, it's a constant, and then we have 3. Okay, what are our like terms?
Negative xy and 3xy.
Negative xy and 3xy. Do we have any other like terms?
4 and negative 7.
Yep, 4 and negative 7, because those are the terms that can be combined. All right. What are our constants? Remember, a constant is a number without a variable part.
4.
4 and negative 7. Okay, so you guys do this one. It's are the same, negative 5 and 4. Good. Okay, we have 56, and then again, 8 times negative x is negative 8x minus x. Okay, now we can combine our like terms. Those are our like terms, so we get 56 minus 9x, because this is a negative 8x plus a negative 1x, so that's negative 9x. Okay, this one. Now the trick here, and you're going to see it again here, and this is something a lot of students forget, is that you need to distribute that negative. So we have 14n minus n, and then this is like having a negative 1 out here. It's minus 2. It's a negative 1 times a positive 2. Okay, then these are our like terms, so we have 13n minus 2. Okay, you guys do the U try.
18 minus 3n.
That's right. So you get 6 minus 3n plus 12, because it's negative 3 times negative 4. Here are our like terms, so that's 18 minus 3n. Multiplicative inverse is just the reciprocal. When you multiply a number by its reciprocal, you get 1. So the product of reciprocals is always 1. Remember to include the negative. The reciprocal of a negative number is still a negative number. So the reciprocal of negative 2/3 is negative 3/2. This is the same thing as 8 over 1, so its reciprocal is 1/8. All right? Now, this needs to be turned into an improper fraction before we can find its reciprocal. So, remember the little algorithm? You can multiply 3 by 5 and then add 2. So that's 17 over 5. So then the reciprocal would be 5 over 17. Okay, what's the reciprocal of negative 1? Any ideas? No, it's actually still negative 1. So this is the same thing as that. So its reciprocal is 1 over negative 1, which is just negative 1. Okay? What do you think the reciprocal of 0 is?
1.
No. Any ideas?
0.
Not quite. 1 over 0. This is actually undefined, and because you can't divide by 0. And we're going to talk about why. I think often in algebra you just hear you can't divide by 0 because it's undefined. We're going to discuss why it's undefined. Okay, so the definition of division says A divided by B is C. If A times the reciprocal of B is C, where B is not 0, because you can't divide by 0. Okay. Okay, so here's the interesting thing. Notice what happens when you try to divide by 0. 5 divided by 0 is what? Well, that's the same thing as asking what times 0 is 5. What times 0 is 5?
0.
0 times 0 would
5.
be 0. 5 times 0 would be 0. What times 0 could be 5? There's nothing, right? there's no value that makes that true. Or you could write nothing works. Nothing works. So that's why we say dividing by 0 is undefined. It doesn't fit the definition of division. Okay? That's why they say you can't divide by 0. The rule, the division rule for real numbers follows directly from the definition of division. It's almost the same thing. So the definition of division was up here. Division rule for real numbers just says to divide a number by a number A by a non-zero number B, multiply A by the reciprocal of B. It's really saying the same thing. Now, just like with multiplication, a quotient of two numbers with the same sign is positive, so a negative divided by a negative is positive. When dividing two numbers with different signs, the quotient is negative. Okay. So here, our quotient is going to be positive. We know that. I can't multiply by the reciprocal unless I make this into an improper fraction. So this is negative 3/8 divided by negative 9/4. All right. So now, if I'm going to multiply by the reciprocal, this is the same thing as negative 3/8 times the reciprocal, negative 4/9. All right, we know we're going to get a positive. I can cancel these, right? 9 and 3, and I can cancel my 8 and my 4. I get 1 and 2. So now I have, we know it's going to be positive, a 1 in the numerator, and 2 times 3, which is 6 in the denominator. So now you do this one. So you might have learned this little trick. You can say copy the first part, dot, and then you flip this, copy dot flip, which is not math language, but it's the same, it's the same thing as saying multiply by the reciprocal, which is math language. But if you've seen that copy dot flip, and if that helps you, that's great. Make that a dot. Okay, now we can cross cancel, and then we get, the answer is going to be a negative because we have different signs, and we get 15 over 8. Now in algebra, I think I've mentioned it before, I like you to leave this as an improper fraction. In general, the only time I actually change it back to a mixed number is for graphing, because it makes graphing easier. Okay. Evaluating the expression. Here's where we substitute in the values of the variables into the expression. This one's going to have a lot of negatives, so we're going to put the negative 6 every time we see x. So this is 3 times negative 6 minus negative 2. Watch those negatives. It's minus a negative over negative 2. Okay, well, 3 times negative 6 is negative 18. If you subtract negative 2, it's the same thing as adding the opposite of negative 2, so you're adding positive 2. Minus a negative is the same thing as plus. Okay. So then this is negative 16 over negative 2. Negative divided by a negative, same sign, so it's going to be positive 8. You do the U try. Okay, so why don't you work on your homework? It's only about 5 minutes, but see how much you can get done.